So this is an exercise related to distance, displacement, speed, velocity and acceleration. Exercise 2. In the first part, in question 1, a boat is moving at a constant speed. On a figure, sketch a distance time graph for the boat. So whenever a boat or object is moving with a constant speed and a distance time graph for constant speed, it will be a straight line which is passing through. Origin shows that it is a constant speed or constant gradient. For question 2, in question 2, a car accelerates uniformly from rest at 2.2 meter per second square for 3 seconds. Calculate the speed of the car at time is equals to 3. So basically, after 3 seconds, we have to calculate the speed of the car. And they mention a car accelerates uniformly from rest. So if something starts from rest, the starting speed is 0. So when we say we have the formula for acceleration, the formula of acceleration is the final speed minus initial speed divided by time. So what is the acceleration given? Acceleration they mentioned 2.2 meter per second square, because meter per second square is a unit of acceleration. What about the time? The time is equals to 3 seconds. What is the initial velocity? Because it starts from rest. So whenever anything starts from rest, its initial velocity or starting velocity is 0. So we have the formula A is equals to V minus U over T. A is acceleration, which is 2.2. V is the final speed we are finding, U is the initial speed, that is 0, and divided by time is 3. So this 3 is divided, other side it will be multiplied. So it will be 2.2 multiplied by 3, and V minus 0 is basically V. So 2.2 multiplied by 3, that's equal to 6.6 meter per second. Is it clear? Question 2 part 1. In the question, they mention a car accelerate uniformly from rest. So means a car starts from rest. Whenever anything starts from rest, what is the starting speed? The starting speed is 0. U is called the starting speed or initial speed. And it has an acceleration. This is the acceleration of the car, which is given 2.2 meter per second square. So acceleration is given 2.2 meter per second square, and it accelerates for 3 seconds. So for how long, or what is the time interval it accelerates? So it accelerates for 3 seconds. They're asking calculate the speed at time is equals to 3. So basically we want to calculate speed when time is equals to 3 seconds, or we want to calculate its final speed. So V is needed. So you have the formula A is equals to V, the final speed, minus initial speed divided by time. A is the acceleration, which is 2.2. The final speed is unknown. Initial speed is 0 and the time is 3. So this 3 is divided. Other side it should be multiplied. So 3 multiplied by 2.2. That will make 6.6. So the final speed is actually 6.6 meter per second. Is it clear now to everyone? The second part, calculate the average speed for 3 seconds, and when time is equals to 3 seconds, it has traveled a distance 9.9. So how to calculate an average speed? The formula for average speed is equals to total distance divided by total time. That's a formula for average speed. So the total distance which this car covered, that is 9.9 as I mentioned here, divided by time 3 seconds. So 9.9 divided by 3. So 9.9 divided by 3, this will give you the average speed, which is coming out as 3.3 meter per second. Is it clear, the second part? The average speed. So the formula for average speed is the total distance divided by total time. And the third one, on figure 1.1, is sketch a distance time graph for 3 seconds. So as they mentioned in the beginning, the first part, the car is accelerating. So if something is accelerating, what should be the distance time graph? So the distance time graph should be a curve, and the slope of this curve should increase. Because they already mentioned, this is a continuation of the question. So they, in the beginning, the first sentence they mentioned, the car accelerate. So when something accelerates, something speed up, so the what should be the curvature? It should go up, or the angle should increase. So it's not, it's just a sketch. So for a sketch, it can be any way you can draw a curve, but it could not be a straight line as it is accelerating. Yes, Abdullah?
Sir, but they are saying till to it's uniformly.
Yeah, accelerate uniformly means acceleration is constant. Like example, if I say the car was at 0 meter per second initially, then it is 2 meter per second, then it is 4 meter per second, then it is 6 meter per second. So speed is increasing, but acceleration is constant. Here acceleration is 2, acceleration is 2, and acceleration is 2. Uniform acceleration means acceleration is constant. So for a
So it
distance,
won't be straight.
no, no. If it was a constant speed, this is a distance time graph. So if it was a constant speed, then it will be a straight line. If it is a constant acceleration or accelerating, then it will be a curve. This is representing accelerating or acceleration or uniform acceleration. And if it was decelerating, like speed was decreasing, then it should be like this for a distance time graph. Is it clear?
Yes,
So
sir.
accelerate uniformly means acceleration is constant and speed is continue to increase. Is it clear to everyone? So this was question 2. Then in question 3, figure 1.1 shows axis of distance and time, axis of distance and time for an object moving in a straight line. On a figure, draw between time t is equals to 0 and 10 seconds the graph of object which is moving at a constant speed of 5 meter per second, and start your graph with a distance 0 meter. So how we can complete this graph? As they mentioned, it is moving at a constant speed. So if it is moving at a constant speed, so there should be a straight line for a distance time graph. But what should be the distance it travel? So we have the formula speed is equals to distance divided by time. So to know what distance it cover in 10 seconds, so speed is 5, which is constant, distance we don't know, and in 10 seconds the time interval is 10. So this 10 is divided, other side it will be multiplied, so 10 multiplied by 5, that's equal to 50 meter. So this object will cover 50 meters in 10 seconds. So when it is at 10 seconds, it will cover 50 meter, and each box is representing two each box is representing 4 basically, not 2, because 10 boxes equals to 40. So this is 44, this is 48, and between 48 and 52 it will be 50. So 50 will be here on the graph, because this is first box after 40 is 44, then it will be 48, and after that it will be 52. So we need distance 50, so this is a distance 50. So when time, and it's a constant speed, so it will be a straight line. After 10 seconds the object will cover a distance of 50 meter. Is it clear, this graph? Yes, Abdullah Sarfraz, you have question?
No, sir.
Heather, Lamia, Mira, Yusra, any doubt? Is it clear? Then state the property of a graph that represent a speed. So speed from distance time graph, the gradient or the slope represent the speed. Like the angle, the gradient, the slope is representing the speed of a distance time graph. Another part, why it is of 2 marks. 1 mark is for the graph and 1 mark is for mentioning that the gradient represent the speed. Between time t is equals to 10 second and t is equals to 20 second, the object accelerate. The speed when time t is equals to 10 second, when time was 10 second, the speed was 5. When time is equals to 20 seconds, the speed is 20, or 9, sorry, not 20, that's 9. Dimension here, speed at 20 second was 9. Calculate the average acceleration. Average acceleration, total acceleration, they all have the same formula. So acceleration is the final velocity minus initial velocity divided by time interval. So the final velocity is 9, initial velocity is 5, and what about the time interval? Because from 10 seconds to 20 seconds, so what is the time interval? So time interval is 10 seconds, so we'll write 10. So 9 minus 5 is equals to 4, and 4 divided by 10, so what is the acceleration? That's equal to 0.4 meter per second square. Is it clear? The second part, when time was 10 second, the speed was 5. When time is 20 second, speed is, like if I draw a figure, the speed changes, and when the time was 10 seconds, the speed was 5, and when time is 20 seconds, the speed is 9 meter per second. The question is, what is the acceleration from moving from time 10 seconds to 20 seconds? So the change in the velocity divided by time. Acceleration is the change in the velocity divided by time interval. So when time is 10 seconds, the speed of the object is 5. When time is 20 seconds, the speed of the object is 9. The question is, what is the acceleration? So how to get the acceleration? Acceleration is the final. So what is the final velocity? That's 9. Minus initial velocity. What is the initial or starting velocity? That's 5. And what about the time interval from 10 seconds to 20 seconds? The time interval is 10. So 9 minus 5 is equals to 4, and 4 divided by 10, that's equal to 0.4 meter per second square. Is it clear, Abdullah Sarfraz? In question 4, figure 1.1 is a distance time graph for a train for 120 seconds. So for 120 seconds, this train is moving. What is the average speed? So how to get the average speed? The formula to calculate the average speed, that is the total distance divided by total time. So when total distance divided by total time, that will give us the average speed. So first we should get the total distance. So this is the total distance travel. Each box is representing 100. So this is 4,800 meter. And the total time is 120. So to get the average speed, 4,800 meter divided by total time, which is 120 seconds. So 4,800 divided by 120, which is equals to 40 meter per second. Is it clear? First part, A1. As the average speed is the total distance divided by total time. Why it is not 4,998? Because each box is representing 100. As you can see, from 0 to 1000 there are 10 boxes. So if 10 boxes representing 1000, so each box is representing 100. So this is 4100, 4200, 4300, 400, 500, 600, 700 and 800. So one box is representing 100, that's why it is 4,800. Then the second part, speed of a train at time is equals to 100 seconds. So how we can work out the speed when time is equals to 100? So we have to only work out the speed for this part. Only this part, the straight part, because here the speed is constant. It's a straight line till in this region, like where I draw a line, red line, this part the speed is constant, and here the speed is changing because here the speed is increasing. The black part is representing increasing speed and the red part is representing a constant speed. So we want to find the speed in this part of this part. So only the straight part or 100 second, because it's a straight part, so we can find the speed for any region. And how we can work out the speed in this region, as it is a constant speed? So we'll find the distance travel in this region and then we'll find the time. So how to get the distance travel in this region? When the speed is constant, example, one of the distance in the constant region I took 2000 and the second distance is 4,800. So what is the distance travel because in a constant place, with a constant speed, it travel from 2000 to 4800. So what is the distance travel in this region? So it covered 2800 meters. And what about the time interval? How much time it took for this distance? On x-axis, each box is representing 2. So this is 62, 64, 66, 68, 70, 72, 74. So this is 74 and 120. So the time interval from 74 to 120. So 120 minus 74, that's equal to 46. So it took 46 seconds to cover this 2800 meter. The question was calculate the speed at 100 second. So when we are checking the graph at 100 second, it is a straight line. So it means in this part, speed does not change. So we can find the speed of this part, and after finding the speed of this part, that is same as the speed at 100 second, because the speed does not change due to the straight line. So the distance travel in this region for a straight part, the distance travel is 2800 and the time is 46 seconds. So it will be 2800 divided by 46. So it will be 60.86 meter per second. That's the speed at 100 second, or that you can say that can be a speed from a region. It's not till 100, they're asking speed at 100. So basically in this region from 74 seconds to 120 seconds, the speed does not change. How we can identify speed does not change? You can see it's a straight line. So if I can find the speed of this part, it means that is the speed for the time interval. It can be for speed at 80 second, 90 second, 100, 110 or 120. Because it's a straight line, so speed does not change in this region. Is it clear? This part, calculating the speed at 100 second, or if the same question was there, calculating a speed at 80 seconds, so you will get the same answer. Because in this part, the speed does not change. In the question, they are saying, calculate the speed of the train when time is equals to 100 second. So when time is 100 second, the question is what is the speed of the train? So when you check, when the time is 100 second, that region is a straight line. So it means that the speed of this train does not change in this region because it's a straight line. So speed does not change. So what I can do, I can determine the speed of this part. And how I can determine the speed of this part? I can find the distance travel. So I can find the distance travel and I can use the time interval. So distance divided by time, that will give me the speed. And that speed is actually the constant speed. So speed is not changing from this time interval, like example from 74 second to 120 second. Is it clear, Abdullah Sarfraz? So if the same question was there and instead of 100, they mentioned calculate the speed for 110 at 110 second. So you will do the same thing. because the speed from 74 to 120 second does not change, so you can find anywhere using a distance and time, you can find the speed of that region. In question 5, a lorry is traveling along a straight horizontal road. Figure 1.1 is a distance time graph for the lorry or a truck. Using figure 1.1, determine the speed when time is equals to 30. So when time is equals to 30, basically again a similar question. The speed of the lorry is constant in this part. It does not change till this point. So means the speed from 0 to about 70 second remains same as it is a straight line. So if this was a question, they asked calculate the speed for 10 second, 20 second, 30 second, 40 second. It will be same because it's a straight line till 70 seconds. So speed does not change. So how we can determine the speed? So we'll find the distance. It started with 0 and ending till 2000. So the distance covered is 2000. And what about the time interval? So when I check this time axis, each box is representing 2. So this is 62, 64, 66 and 68. So the time interval is 68. To get the average, to get the speed at time is equals to 3. So it will be 2000 divided by 68. So 2000 divided by 68 will give us 29.4 meter per second. So that is the speed of the lorry when time is equals to 30 second. And actually that is the speed of the lorry when time is equals to 20 second, time is equals to 30 second, 40 second, 50 second until 68 seconds, because it does not change the speed as it is a straight line till 68 seconds. Is it clear, the first part? The second part, find the average speed. So the average speed from 60 seconds to 20 seconds. So how to calculate the average speed? Total distance divided by total time. But we don't need the average speed for the full motion. We need the average speed for from 60 to, what if they ask for 90 second? For example, Hatim, your question, for what if they ask for speed at 90 second? So if they ask for speed at 90 second, then what you have to do, if it's a curve, you have to draw a tangent. Like you used to calculate the acceleration from a speed time graph. So if it is a curve, then you have to draw a tangent. But normally they do not ask for this. That's why we are not going in detail. But if they ask, then you have to draw a tangent at 90 second and find the gradient, and that will be the speed. So to calculate the average speed when time at times equals to 60 second to 120. So how we can work out at 60 second, what is the distance covered? Each box is representing 100. So this is 1800. So at 60 second, it is 1800. And for 120 second, it is 2700. And the average speed is the total distance travel divided by total time. So what is the distance travel from 1800 to 2700? So you will subtract 2700 minus 1800, that's 900. So the distance travel is 900 meter, and the time interval from 60 to 120, the time interval is equals to 60. So when we calculate the average speed, the distance travel is 900 and the time interval is 60. So 900 divided by, why it is 1800? As you can see, each box, because from 0 to 1000 there are 10 boxes, so each box is 100. So this is 1000, 1100, 1200, 300, 400, 500, 600, 700 and 800. So each box is 100, that's why this is 1800. So final answer will be 900 divided by 60, that is equals to 15 meter per second. As they asked for average speed from 60 to 120 seconds. They did not ask the average speed for the total journey. If they ask for average speed of the total journey, then I will take the final distance directly. I'll take the final distance, which is 2700, and I will take the final time, and total distance divided by total time, I'll get the average speed. But I will not use this method here, as they ask the average speed from 60 seconds to 120 seconds. Is it clear, this part? Yes, Abdullah?
So in part 2, the total distance is 900.
Yeah, because they mention you want to calculate the average speed from 60 second to 120 second, between 60 and 120. So when it was 60 second, the distance was 1800. When it is at 120 second, the distance is 2700. So what is the distance travel between 60 to 120 second? So when I subtract, that will come out as 900. Clear?
Yes, sir.
And the time interval, because it started with 60 and 120, so the time interval is 60. And in question 6, figure 1.1 is a distance time graph for a moving car. On a figure, mark a point where acceleration is 0 when the object is moving at a constant speed, because this part, it's a constant speed. The black part is representing a constant speed, and this part is representing speed is increasing. So when the object is moving at a constant speed, what is the acceleration of the object? When the speed is constant, the acceleration is 0. So on the figure, we have to label a point P where acceleration is 0. So we can write acceleration anywhere. We can mark P anywhere on this straight line, as the speed is constant and acceleration is 0. The second part, determine the speed of a car when 15 seconds. So speed of a car at 15 seconds. So basically, this region, the speed of the car is constant. So what we can do, we can use the total distance. We can find the speed in this region. So the distance travel divided by time, as it is a straight line, so I can find the speed of this region, and the speed of this region is same as speed at 10 second, 15 second, 20 second, 25 second or 30 second. So this is 150 and then 30. So 150 divided by 30. So I will get 5 meter per second. And the last part, average speed from 30 second to 45 second. So again, the same way we'll calculate the average speed. So when time is equals to 30, we'll get the distance travel, And when time is 45, 41, 2, 3, 4, and 5. So what is the this is 150. So from 150 to 300, the distance travel is 150, and the time interval from 30 to 45, that is 15. So to get the average speed in the last part, it will be 150 divided by 15, which is equals to 10 meter per second. Is it clear? The last part, B1 and 2. Yeah, the last part, B1 and 2. The speed of a car at 15 seconds, because it's a straight line in this region, so we can find the speed of this region, and that speed will be same as the speed at 10, 15, 20, 25, or 30 seconds. And the next part, we need average speed from 30 to 45 seconds. So this is a 30-second interval, and this one is 45. So we calculate B1. You want the speed of a car at 15 seconds. So we want the speed when time is equal to 15. 1, 2, 3, 4, and 5. So this is 15. So what we can do, because in this region the speed does not change. So I can find the distance here. I can use this distance divide by time. I get the speed, or I can find the total speed of this region. And that speed of this region does not change. So when time is equals to 30, the distance traveled was 110, 20, 30, 40, and 50. So this is 150 the distance travel, and the time it took 30. So this region speed does not change. So 150 divided by 30, that's equal to 5 meter per second. So actually the speed of this car is 5 meter per second when time is equals to 10 second, 15 second, 20 second, 25 second, or 30 second, as the speed is constant in this region. Is it clear, Hatem? So this was the weekly homework exercise related to the distance, displacement, velocity, and acceleration. Any question related to the class? Yes, Abdullah? You have a question, Abdullah Sarfraz? Okay, so I'll end the session and share this with you.